Okay, so let's have a go at this one then. Let's have a go at this one. I think first of all what we should do is go through and check the dimensions of each matrix. Okay? So what are the dimensions of A? Yeah, 1 by 3. You happy? So A is a 1 by 3 matrix. There's 1 row and 3 columns. What are the dimensions of B? 2 by 3. Girls, can I have a bit of quiet, please? Thank you. What are the dimensions of C? Good, 3 by 1. What are the dimensions of D? Yeah, 2 by 2. And what are the dimensions of E? 2 by 1, perfect. Okay? So all we need to do then, now we've written the dimensions down, is work out which pairs are possible. Now the way which I've written this, ironically I've written it as a matrix, okay? This is my first matrix, okay? So if you like, this is the matrix that goes on the left of my multiplication, the way which I write my multiplication. And this would be my second matrix, okay? So for instance, that square there would correspond to A multiplied by B. So it would correspond to A multiplied by B like that. Now you remember we looked at this on Monday, the order matters with matrix multiplication. So that would not be equal to B times A. Okay, so you've got to be careful about the order. Does anybody remember the word for this, where you can't switch the order around? Begins with a C. Yeah, good. So it's non-commutative. It means you can't do it the other way around. Okay, good. Okay, so let's have a look at this. Sorry?
They're not the same.
Yeah, exactly. You can't just switch the order around. You need to be careful about the order. Okay, so let's check this. So we've done one of these already. Can we do A times B? No, because the columns don't match up with the rows. Okay, so A times B is not possible. Okay, can we do B times A? No, because B times A would be using the columns from this matrix and the rows from this matrix. They're not the same. Okay, so we also can't do this one. Can we do A times A? No, because if you think about it, this column does not correspond with the row. Okay, so we also can't do that one. All right, can we do A times C? Can we do A times C? Yeah, I think so, because the columns match up with the rows. So I think that's definitely possible. Can we do C times A, though? Can we do it the other way around? Yeah, I think so, because the columns match up with the rows. So that's also possible. Okay, good. Can we do B times B? B times B, B times itself. No, I don't think so, because the columns don't match up with the rows. Okay, so the columns don't match up with the rows. Okay, can we do A times D? Okay, so the columns don't match up with the rows, so we can't do that one. But can we do D times A? Nope, because the columns don't match up with the rows. Okay, let's go through then. Can we do A times E? A times E? Nope, because the columns don't match up with the rows. Can we do E times A? Yeah, absolutely, because the columns match up with the rows. So that's possible. A times E, E times A is possible. Okay. Can we do B times C? Yes, we can, because the columns match up with the rows. So B times C is possible. Can we do B times D? No, because the columns don't match up with the rows, so that's not possible. Can we do B times E? No, absolutely, because that column does not match with the number of rows. Can we do C times B? No, because the number of columns does not match up with the number of rows. That's not possible. Can we do C times C? No, because the number of columns does not match up with the number of rows. Okay, so C times C is not possible. Can we do C times D? No, because the number of columns does not match up with the number of rows. What about C times E? No, because columns does not match up with rows. Can we do D times B? Yeah, because the number of columns matches up with the number of rows. That's possible. D times B. Can we do D times C? No, because the number of columns does not match up with the number of rows, so D times C is not possible. Can we do D times itself, D times D? Yeah, absolutely, because the number of columns does match up with the number of rows in that case. Can we do D times E? Yeah, because columns matches up with rows. Can we do E times B? No, because columns does not match up with rows. Can we do E times C? No, because columns does not match up with rows. Okay, last two then. Can we do E times D? No, because columns does not match up with rows. And can we do E times E? No, absolutely not, because columns does not match up with rows. Okay, so there was two things that I wanted to show you there. Number one, you need to be really careful about the order. So for example, we can do E times A, but we cannot do A times E. Okay, so in general, if we can do one, we can't necessarily do the other. So if we can do the first matrix multiplied by the second matrix, it doesn't mean that we can switch the order around. Okay. The other thing which I wanted to highlight to you here is that if we multiply a matrix by itself, what is the condition in order for us to do that? Like, how do we know that we can multiply a matrix by itself? What are the condition about the dimensions of that matrix? Absolutely, they have to have the same number of rows as columns. If you have a look, we couldn't do A times itself, B times itself, C times itself, or E times itself, because each of these dimensions do not have the same number of rows as they do columns. However, we could do D times itself. In other words, we could do D squared, which just means D times D. Okay? We could do that because we have the same number of rows, the same number of columns. Now, when we have the same number of rows as columns, does anybody know what we call those types of matrices? When we have the same number of rows as columns? We call them square matrices. Okay? Squared, in other words, you can square the matrix, but also square because it's the same in the rows direction as it is in the columns direction. If you think about a square, the definition of a square is that all sides are the same. Okay? So in this case, we have the same number of rows as we do columns. Okay? So this we would call a square matrix. Okay? So there are a few interesting matrices out there. I will show you a couple more. Okay? But this is the first one that I want you to show. If you've got the same number of rows as you do columns, we call that a square matrix.